Insecure deserialization. It's a bit of a mouthful, and we're going to be talking about what insecure deserialization is. Then we'll start demonstrating some ways of attacking web apps with insecure deserialization. I hate saying this. It's so unnatural to say insecure deserialization over and over again. But anyways, so what is serialization? So serialization is the process of converting complex data structures, such as objects and their fields, into a flatter format that can be sent and received as a sequential stream of bytes. Serializing data makes it much simpler to write complex data to interprocess memory, a file, or a database, and sending complex data, for example, over a network between different components of an application or an API call. So the reason why applications use serialization is because they need to move these objects either to other parts of the application or between networks, because well, for one reason or another, they can't move the objects as they are. They have to package them first. Okay, so they do this through a process called serialization, which means packaging them up, and then deserialization, which is basically like unpackaging them on the other side. So why do they do this? Well, actually, we just explained why they do this. I've got a little what was it, presentation here that I can show everybody talking about this particular problem. So what is insecure deserialization? Insecure deserialization is a web app vulnerability where the web app uses serialized objects in its function, but does not do so in a safe manner. So when the application is packaging up these objects um, and then unpackaging them, which is serializing and deserializing, there's a potential for somebody to get in the middle of this action and start modifying the serialized objects, and that could be a really bad thing. So what are these serialized objects? Serialization is the process of converting programming objects into formats better suited for transmission between applications or across networks. So when the app needs to use a serialized object, it will use the unserialized function to convert it back into a PHP object. So serialization it doesn't only happen inside of PHP. A lot of different programming languages can do serialization, such as Python or Ruby or Java, or most programming languages are able to do this process of serialization and deserialization. So in this case, we've got an example of a serialized object over here, which is this string over here, which is converted from these two variables. So the user is the name of the object. We've got the name value over here, the name parameter, which is equal to this string called Carlos, and the is logged in parameter, which is set to true. So when we serialize it, we get this format over here. So a bunch of numbers and strings and stuff. We'll explain what this means in just a little bit. Actually, I think I should explain it now so that we're all on the same page. So over here. So if anybody's wondering what we're looking at this article over here from Portswigger. Okay, so the article here talks about PHP serialization format. So PHP uses a mostly human-readable string format with letters representing the data types and numbers, representing the length of each entry. For example, consider a user object with these attributes. So we've got the example over here. So the object is called user. And then we've got name equals Carlos and is logged in equals true. So when we serialize it, the object may look something like this. So we've got O:4 and then user:2 and then S:4 name, S:6 Carlos, and then we got a separate entry, S:10 is logged in, and B:1. So what do these mean? So the first part over here is O4 user. So an object with a 4-character class name, which is user. So the 4 in this case represents the length of these 4 letters. So next is the number 2. That means that the object has 2 attributes. We've got the first attribute, which is S4. So S4 means it's a string with 4 characters. And in this case, it's the word name, which has 4 characters. Okay, and then we've got S6, which is a string with 6 characters, and it's equal to Carlos, which is 6 characters. We also have this over here, S10. So this is a string with 10 characters, and the string is equal to is logged in. So is logged in is equal to 10 characters, so that's why we need to supply this number here. Okay, so the last thing is over here is B. So S stands for string, and B is a different type of data. So B stands for binary data. Actually, no, it stands for Boolean data. So B:1 means true. So if B equals 0, that would mean false, because 0 and 1 are the equivalent of false and true, respectively. Anyways, so the native methods for PHP serialization is serialize, the function serialize, and the unserialized function. So let's go ahead and go back to the presentation. So like we said, the objects are serialized, packaged up, and then they're going to be moved across to different parts of the application, or maybe across networks. If we're able to intercept these serialized objects, we can start manipulating them. So if we're able to get a hold of these serialized objects, we can start modifying them, and then we can send them back to the application, and when they're deserialized, then whatever new values we put inside these serialized objects are going to take effect, which is an attack. So why can deserialization be insecure? So if users can get access to the serialized objects and modify them, the app could be vulnerable to an insecure deserialization attack. So in this case, we've got our serialized object, and we can change our isAdmin value over here to Boolean true, which means that we are the administrator. So, and such an attack could lead to unauthorized access, denial of service, remote code execution, and more. So you can actually do a lot with insecure deserialization depending on how the application is configured. So you might be able to get access to administration functions or any other number of sinister things. So let's go take a look at a laboratory where we can take a look at how we can interact with the insecure deserialization. So this is the link. I will provide it to everybody. So to do these labs, you're going to need to have an account over at, oh, that doesn't work. Sorry. That link doesn't work because it's all split up. Let me get a proper link for everybody. Okay, that should be the proper link that I provided in the chat just now. And let me go ahead and try accessing this link. So like I said, you're going to need an account over at the Portswigger website over here to participate. You don't need to worry too much about making an account over there because it's free. Everything's free over at portswigger.net. And you can just use these laboratories. It's actually very, very generous. So we got a lab. It's called Modifying Serialized Objects. So this lab uses a serialization-based session mechanism and is vulnerable to privilege escalation as a result. To solve the lab, edit the serialized object in the session cookie to hack this vulnerability and gain administrative privileges. Then delete the user Carlos. So the goal is to take advantage of the insecure deserialization and then delete the user Carlos. So it says you can log into your own account by using the following credentials, and we're given the credentials Wiener Peter. So Wiener is the username, Peter is the password. So we can click on the green, on this yellow, oh man, on this orange Access Lab button. We can just put this in a new tab. And if you're following along with us in your own browser, let us know, because I'm always interested to see who's following along with these labs. Okay, so after that, we get access to the vulnerable web page here. So this is pretty typical for Portswigger Academy. We've got a shop page in this case. So what we want to do is we want to log into the application. So we got some links. We've got the home link, and then we've got the My Account link. So we're going to go over to the My Account link. Then we're going to log in using the provided credentials. So if you remember, the provided credentials are Wiener and Peter. So use those to log in. And now we have access to our home page. So my account, your username is Wiener. Great. Okay. So what we're going to do now is we're going to take a look at the serialized object in the cookie and the session cookie. So we're going to access the cookie inside of our browser. So if you don't know how to do this already, this is a good place to learn. What you want to do is you want to go over to the corner of the web browser, and there's going to be this little hamburger menu over here. You can click on the button, and then you can click on, go to the bottom here. There's going to be an option labeled More Tools or Web Developer Tools. Go ahead and click on that, and then click on Web Developer Tools. This is kind of similar between Firefox and Google Chrome. It might be slightly different in whatever web browser you're using. But go ahead and click on Web Developer Tools. You're going to see a bunch of different tabs over here. So these are all the Web Developer Tools. What we want to do is we want to locate the storage tab. So there's going to be either an application tab or a storage tab. You want to click on that, and then you want to click on cookies. So click on the cookies here, and you're going to see cookies for this particular website. Click on that, and then you're going to see we've got one cookie, and the cookie is called session, and we've got a value for the cookie. We can double click on it, double click on the value, and we can copy it. So we're just going to copy the cookie. Then we're going to go over to our console. In the console, we're going to paste in the cookie here. So the interesting thing about this cookie is that this looks very, very similar to base64 encoded data. So this looks kind of like base64. This string here, this could be base64 encoded data. And the way we know this is that we've got this pattern at the end. So the pattern is %3D. So you might think to yourself that base64 doesn't have this percent sign in it. The thing is that this is actually an equal sign. So an equal sign, when you URL encode it, it becomes %3D. We can just delete %3D and replace it with an equal sign instead. And this is a base64 encoded string. What we're going to do is we're going to use the echo command, and then we're going to decode it from base64 on our terminal here. So it's going to be echo-n and then the base64 encoded string inside some single quotes. So make sure whenever you're dealing with a string that has a bunch of special characters in it, you're going to have to make sure that you put it between some quotes. Otherwise, the terminal could interpret it in a weird way. The last thing we do in the command is we pipe it out into the base64 command and decode it using this switch right here, -D. So when we do that, we receive this serialized object here. So the serialized object it looks like this. Let's make the text nice and big. Okay. So what's going on in this serialized object? So the letter O indicates that this is an object, and the object name has 4 characters. So the 4 characters for the object name are user, and it's got 2 attributes. The first attribute, well, the attributes are inside these curly braces. The first attribute is going to be a string that is 8 characters long, and the string is username. The value of that is a string that is 6 characters long, and the value of the string that's 6 characters long is wiener. So remember, when we calculate the length of these strings, we don't count the quotes. The quotes are not part of it. So wiener is 1, 2, 3, 4, 5, 6 characters. And the second attribute is a string that is 5 characters long called admin. And the value of it is going to be a boolean, which is 0. So boolean 0 means false. So how can we get admin access? By manipulating this object. If anybody knows how to do it, let us know in chat. We only need to change one character in this string. So in this case, if we want to give the user, wiener, admin access, all we need to do is we need to set the boolean for admin to 1 instead of 0. Remember, for boolean, 0 equals false and 1 equals true. So admin true is going to give us admin access. And that's going to give us the access to delete the Carlos user, which is the objective of the lab. So how are we going to modify this? We can modify this with the echo command. So we're just going to copy this. Let's make the text a little bit smaller. I'm going to paste in the text. We're going to echo this out and put some quotes around it. And we're going to modify the 0, delete it, and replace it with 1, because that's how we're going to get admin access. The next thing we're going to do is we're going to pipe this into base64. And we're going to make sure that there are no line breaks. So the funny thing about the base64 command on Linux is that after a certain length of line, it's going to insert a line break. And we don't want the line breaks because the line breaks foul up our pasting in. So we want to make sure that w is equal to 0. I need to look up what this actually means. So -w. Let me look that up really quick. So base64 -- help. Okay, so W stands for wrap. So wrap encoded lines after columns character, default 76. Use 0 to disable line wrapping. So we don't want line wrapping. So we're just going to set this to 0 so that we can just get a single line string. Okay. So we give this command, and this is going to be the new cookie over here. So if you don't want to bother using the terminal, I'll provide the cookie to everybody in chat now. Okay, so what we need to do is we need to replace the cookie, the previous cookie, with this cookie, and we should get admin access. So we're going to go back to the application. Anyways, so the session cookie here, we're going to highlight it, double click, we're going to delete the old contents, paste in the new contents, hit enter to set it, and then we're going to reload the page. So from here, reload the web page, and now we see that we have access to the admin panel. So obviously we were able to get the insecure deserialization attack. So we can click on the admin panel, and then we can delete the Carlos user, because that's what we need to do to finish the lab. Okay, then it says, congratulations, you've solved the lab. Awesome. Okay, let's go ahead and close out the lab, and then we'll talk about the next challenge we're going to do to learn more about insecure deserialization.
Hey there, HackerFrogs! Are you enjoying this workshop? Learning new concepts and skills? If so, there's a way you can support the channel, and it's totally free. Just click on the subscribe button below the video. Also, click on the like button. And if you have questions or comments on this workshop, please leave them below the video. Thanks for listening. And now, back to our scheduled programming.